Okay, so yesterday we were discussing uh, what is it? Just a second, guys. Let me close my WhatsApp. Fine. So we were working on SVN installation, and we had successfully installed the SVN server component. Okay, and this part, and now we need to start working on setting up the repositories and working with the client side. So now from our end, we have finished setting up a server. Okay, the next part is how to set up the client. Okay, so in a developer machine, now treat it yourself like in a developer, this machine, Windows machine, which I'm accessing at the moment, okay, which you're seeing this now, treat it like a client. Okay, and the Linux machine here, whatever it is there, it's a server. Okay, treat it like a server. Now assume, just go to the DevOps folder and say SVN practice. Okay, so this is what my some folder in a developer machine. Okay, and I have some sort of a code base over here. Okay, like source code. Okay, is the one directory I have it. Okay, and something like destination, and also like a new text file, hello dot java, something like this. Okay, so these are the files I have it in my local laptop. Okay, like treat it like yourself as a developer. This is what your source code. Now you want to push this source code to your Subversion server. How do you push it, right? So when it comes to communicating from your developer machine to the SVN server, right? You need to have a SVN client installed on your machine. Okay, so there are different types of clients available. Okay, SVN client. So one is a command line client. Okay, and another is a UI client, and another is an IDE client. Okay, and one more is a browser client. Okay, so let me clarify you that this URL you are accessing in a browser, right, which is nothing but you could able to access the SVN server with the help of a browser client. So the browser client we already use now. Okay, you know what exactly this is, right? So you're already using this. Now you need to make use of the other client, and again the browser client is just a read-only client. What do you mean by read-only client is you can just see the content of the the file and all which are created in the repository, but in a SVN location. Okay, but you cannot modify them. Suppose there is a file called readme.md. Okay, this is created by your uh, SV, this is created by your Bitnami actually. Okay, this readme.file. Okay, now but you cannot edit this file with the help of the browser client. Browser client is only to view the things. Okay, now if you want to perform a write action, okay, so the rest of all three clients supports read and write as well. Okay, now among all these three you have to make use of any one of the client to make the write operation. So I'm going to make use of the command line client because typically for a build and DevOps guys, right, so we mostly work on a Linux machines. Okay, Linux machines are the console based where you need to run the commands and all. You won't be having any kind of a UI tool to perform it. Okay, so let's try to learn the things in a command line. Okay, then I will show you the UI part as well. So there is a tool called Tortoise uh, SVN. Okay, so this will help you to perform the UI operation. Okay, and when it comes to the IDE, this is we can embed this client with Eclipse. Okay, or Visual Studio. So typically Eclipse and Visual Studio are the interactive development environment for the developers. This is nothing to do with us. Developers will install the SVN client on their IDE and they'll try to push their code to the SVN server, right? So this is not required for us. Only thing is we have to concentrate on these two. Okay, the most important thing is the command line one and the uh, tortoise one. Tortoise one is pretty easy. If you know the command line one, learning the tortoise is really easy. Okay, which is a UI component. Now let's first try to install SVN command line client. Okay, so in your Windows machine, see, it can be, again, the command line client can be for Windows or for Linux. Okay, so now at this moment, if you look at the architecture, right, so this is my Windows machine. Typically all the developers will be using the Windows kind of a machines, right, to do their coding and all. Okay, and they push it to their SVN server, which is hosted on the Linux. Okay, now I'm on a Windows machine. Okay, this, my present laptop is a Windows machine. I'm treating like a client. Let's try to install the Subversion client. So Subversion download, just go to the Google and click on this. You can find the Subversion official website. You can find the binary packages over here, and can you see it supports multiple operating system, but we want it for the Windows. Click on Windows, go to the Win32 the plain one. Don't go for other flavors and all. These are specific to the different organizations. Okay, like different like what do you call, community for software, like, Silk SVN, Vandisk SVN. There many are there, but don't use all of them. Directly use the core one. I'm just trying to download this, the MSA file. Okay, seems to be already downloaded. I was not looking at it. Okay. I'm trying to install this. Next, next, next. Don't need to do anything. Just go to the next, next, next. Okay, done. Now, at this moment, I have successfully installed a Subversion client. To confirm whether you installed successfully or not, okay, so try to open a new command prompt, brand new one, okay, and run a command called svn version, or svn version, not hyphen version. If this command is working and you could able to see the version, right, then your command line client is successfully installed. Come on, it shouldn't take this much of time. Okay, maybe it is hyphen version. Yes, sorry. So it's the 1.8.17 is the version which you downloaded at the moment and you install it. So my laptop SVN command line client has been successfully installed. Now let's get into the DevOps practice, okay, and get into the SVN practice. Now what I will do it, okay, to push my code, okay, I'll first try to get the copy of the repository which is hosted on your machine, SVN server. So this subversion is there, right? This we call it as a repository. What do you mean by repository? Is a location or a directory which is hosted on your SVN server, okay, uh, which is like, kept it to store your entire file system, okay, your source code especially. So that that repository we need to get it into our local machine first, okay, then only you can add the code and push it to your server. So the steps are: install svn client, okay, open command prompt, okay, Now what you are supposed to do, you have to run a command called svn checkout, okay, and your repository URL, okay. So your repository URL is nothing but this entire URL. Just take this URL, svn checkout, okay. This is successfully checked out. So what exactly successfully checked out means? Can you see Subversion folder here? Okay. So this is what your repository. Whatever you see it in the browser, you can see the same thing over here. Readme.md. Can you see this? And the file can be opened. So you could successfully download it, the file from your repository. Now what you are supposed to do to push your code. Your code is outside of this directory, right? Now what I will do it, take this code, Control X, and keep it inside your location, download location, and this download location we call it as a workspace in our terminology. Okay. Now this checkout command creates workspace. Okay. So Subversion is what your workspace. Okay. Now if you wanted to push any of the files, you have to keep it inside this directory and you have to push it. So now I kept all my files inside this directory. Okay. Then once you keep all your files, right, now get into your Subversion folder. Okay, and try to run a command called svn status. The status will tell you your workspace status. Okay, what is exactly happening in your workspace? It says like in a question mark symbol to all your files, the new files. Okay, not to the readme, because readme is already part of your workspace and it is already part of your repository as well. Okay, so these are all the new files present in your workspace area. Now if you wanted to push these files to your server, right, first and foremost you have to add these files, like hello.java.txt. okay. Now once you added that, try to run the status again. Can you see a symbol here? This file has been added. Now if you try to commit now, right, okay, if you want to commit the files, I mean committing nothing, but if you want to push it to your server, right, you have to run a command called svn commit, okay, and the file name, okay, and you have to provide a tracking message which is also called log message. Say like this is my first file, commit. That's it. Now you have successfully pushed your file to your SVN server. Can you see this now? Refresh this page, because this browser client directly access your SVN server. Now you can see hello.java.txt. Okay. Now you might be thinking, where are other two files? Other two files I didn't commit it, guys. Look at this. Other two files are lying over there in your workspace only. Now I wanted to add other two files. So tomorrow there might be a number of files. You cannot keep add like one by one. So give just star. Okay. So when you give star, what will happen? SVN status, it will add all files which are in a kind of it will add all the files which are in a question mark state, which is nothing but unknown state. Okay, unknown state files are kind of like non-workspace files, so it will add it. Now if you want to commit all files together, commit, don't provide the file name, just say like bunch of files. I mean, just provide the message, that's it. Bunch of files committing, that's it. Now you come back here and check it out. Can you see both the directories are added? And if you really observed or not, it is keep incrementing a revision number. Earlier it was 2, now it is 3, in the beginning it was 1. So every commit transaction, it will try to increase the revision number. So what you are doing it, svn add file name and then svn commit file -m some command. Okay, so this is what the syntax of your command. If you want to commit all the added files, svn commit -m, don't provide the file name, bunch of files. Okay, so it will add all of them, right? So every commit increments the revision number in SVN repo. Okay, what do you mean by SVN repo is whatever you see it here, right? This subversion is called SVN repo, and it keep increments the revision number. Okay, so you might be thinking, what do you mean by revision number? Revision number is a tracking number. Okay, I'll give you the benefits of it later. Okay, let's try to perform the rest of the SVN client commands. Now, if you try to run the SVN status, can you see empty? Nothing but your workspace code base and your repository code base both are same. There is no change in it. Okay, so you don't have any changes on your local workspace. Now, if you try to commit something also, nothing will be committed because there are no changes, right? So this is how you add a single file, you add a bunch of files. Okay, now your addition is done. Now let's try to perform some other operations like kind of a modification. Hello.java. Hi. Some changes. Okay. Now you come back and try to run the status. Can you see this? M nothing but modified. Your file has been modified in your local workspace. Now, if you wanted to reflect these changes into your repository, okay, so which is over here. So right now the changes are not there over here. Now let's try to commit this file. svn commit -m modified hello.txt. That's it. Now it's a revision number 4. So even a modification also a revision number. Can you see if I refresh it? I can see my changes over here. Okay. So that is what the modification. Now if you wanted to delete something, okay, so typically the deletion will happen with the command called svn delete. Okay, and this I'm trying to delete a directory actually. So it's been deleted now. D nothing but deleted. Svn commit -m deleted test directory. That's it. It's been deleted now. And try to refresh, and fifth revision number, the file has been the directory has been deleted. Okay, now when you're doing the n number of transactions like this, okay, the main motive of going for the source code management tool is to getting the history of your file system, right? So if you remember the yesterday's session, in the middle of the session, right, I was talking about why we are going for the source code management system. Okay, the reason it is the source code management system maintains versions for each and every change which you make it on your file system. Okay, now it's a time to prove how SVN is maintaining the history and how we can able to track it. Okay, so try to run a command called svn update, so that what it will do, it will make sure it will update your workspace up to date with your repository. Okay, now try to run a command called svn log. This log will show you the entire history, what is happening from the beginning of this repository. Could you look at this? When you install the SVN, right, so Vagrant is a user which created a file called readme, okay, which is yesterday. If you can see the timestamp, so it will give you an answer for 3 questions for you. Okay, so typically with any SCM tool, okay, you will get an answer for who committed, who made the changes, okay, when they made the changes, okay, and what they made it, right? This is, I mean, you will get an answer for all these 3 things. Okay, if you could able to get the answer for these 3 questions, right, that's it. You can track each and everything, and you don't have to worry about it. Okay, so look at this. Now the Vagrant is the user. This is what the author. Can you see this? This is what the author. Okay, and this is what for the who answer, and this is the when answer, like when yesterday it was. Okay, and what exactly is modified? See, the comment message clearly says this has been, it is modified, and same thing for the rest of us. Okay, only thing is you see no author for these comments. The reason behind it is we didn't create any kind of a security policy on our SVN system. Okay, so we need to enable the security part on our SVN server. That we didn't do it. We'll do it later as part of the SVN administration, guys. Okay, so we'll again come back to the server part. Okay, so server part, there are 2 things. One is installation, okay, and other is administration, right? So we are done with the first part, but we are not done with the administration, so we'll come back again there. Okay, so what we are trying to learn is a developer point of view, okay, which is a usage. We are trying to learn the usage part first. Okay, so once the usage is done, and we'll go back to the administration side. Okay, so first of all you should know what exactly a developer does, then only you can do some sort of a help to the developer, right? Now, so this is what the history one. Okay, with the svn log command, if you want to know a particular a revision history, right, we can give a log revision number R1, R4, the particular revision number. If you try to provide the unknown revision, right, R7, there is no 7 revision number, so to throw another. Okay, so this these are like a set of commands which will helpful for the developers or who are accessing the SVN client. They can manage pushing the code and pulling the code. Okay, this is with the one developer. Think about there is one more developer. Okay, I'm opening another command prompt. Okay, and get into the DevOps and mkdir developer 2. Okay, get into the developer 2, and the developer 2 is also working on the same code base. Okay, what happened? Okay, sorry, I need to provide the where I should be there in this directory. Okay, get into the Subversion. Now this guy is a developer 2. Okay, now he is also working on the code. Now assume he made some changes to your file echo hello uh, hello.txt. Guys, we can make use of echo command even in the DOS as well. No need to worry about it. SVN status. Can you see this? This file has been modified. Okay. Now SVN commit -m. Okay. Modify the hello.txt by dev2. So the developer 2 made some changes. Now we look at the architecture. Okay. So treated this guy as like a developer 2, and he is your developer 1. Okay, so we work till now developer 1, now we start working developer 2. Okay, now this guy pushed the code. Okay, now you look at your server, you can find hello.txt with do a control F5. Okay, can you see hello here? It's been appended. Okay, so now if you come back to your developer 1, and this guy don't have that hello here. Okay, so he still don't have changes. So if you wanted to get the changes from the your repository, right, so what you're supposed to do it, run svn update command. This will pull the latest changes from your repository or local workspace. Can you see this? This has been updated now in his machine. Okay, now you can see the hello over here. So the developers can keep update their workspaces by running a command called svn update. Not only that, you can go back to a certain state with the help of the svn update command. So now you look at this, you have this set of files, right? If somebody asks a question, I wanted to know how exactly my file system looks like in a revision number 1, I mean in the beginning of the project, okay, which is -update R1. Yeah, any questions?
Can you explain the what is the meaning of R1 and R2?
Could you please speak a little bit louder? I can't hear you.
Can you explain the meaning of R1 and R2?
I see so much of noise. I hear so much of noise. Could you please type over there in the chat at least?
Explain the meaning of R1 and R2. R1 and R2.
Okay, R is a revision number. 1 nothing but it's a revision number. It's a unique number assigned. Like you can see over here in a repository there is a revision number is assigned, right? 1, 2, 3, 4, 5, 6. That's called the R. 1 nothing but revision number 1. Did you get it?
Okay.
Yeah. So look at this. In our revision number 1, there is only one file in your workspace. Can you see this readme.md? There is nothing is there. If you want, you can cross check it. Okay. In revision number 1, there is only readme file. And in revision number 2, when you update to revision number 2, can you see this hello.txt we added? Okay. And in revision number 3, how it looks like? We added 2 more folders. Can you see this? And in revision number 4, we deleted a file. We updated some content over here. Okay. And revision number 5, we deleted the directory, right? So with the help of a svn update command, you can go back to the any state of your repository. Okay, that's the benefit of it. So now this is going to give a nice benefit to the developers in case if they are working from last 1 year on a project. Okay, and somebody wants to roll back their code to a particular day, they can easily roll back with the help of the revision number, and they can go back to that revision and they can see what has been committed over there. Okay, and they can get the changes. Right, so this is what revision tracking. Okay, let me put it in a diagrammatical way so that you can understand. What is paint? I need. Can't I open another paint? can't open another instance. Fine. So I'll just make use of this corner one. Treat it like a straight line, something like this. Okay. When your repository is created, okay, default the Subversion will assign a revision number called 0. Okay. A revision number is a unique snapshot number, okay, which will be assigned to every transaction happens on your repository. Okay. Now, when you install your repository through Bitnami, right, Bitnami default creates one file called readme, okay, right, like how you added a file and how you committed, right, similarly Bitnami would do it in the backend, okay, and when it is committed a readme, right, it will have incremented the revision from 0 to 1, okay. Now when you install your entire SVN server, you will be getting with the revision number 1, okay. So but actually if you install manually, right, it will be 0 only, okay. As Bitnami created one file, you can see revision number 1. Then onwards, like, you proceeded like, committing multiple things, like, in revision number 2 you committed something, okay, in revision number 3 you committed something. So this is like, never ending. You can commit n number of things and it will keep incrementing it, okay. Example, like what I would say is, if your current revision number is n, okay, after commit, the revision number will become n plus 1. This is a formula, guys, nothing else, okay. So always remember, if your revision number is n, after a commit, your revision number is going to be n plus 1. That's it, okay. And revision numbers are unique, okay, and these revision numbers are also called as a versions in other terminology. A revision or a version, all are same, okay. So that's the concept behind the SVN system, okay. Not only SVN, all the version controlling systems or all the, like, all the SCM tools, any of the SCM tools works based on this concept only, versions concept, okay. So as it is based on the versions, and we could able to control this version, controlling nothing but we can go back to the any of the version, right, any of the region, right. So that's the reason these systems are also called version control systems. These systems are also called version control systems, okay. I can write it down over here so that it is useful for you. Version control system, okay, also called VCS, okay. Remember, guys, in interviews and all, they ask you, do you know SCM tool, do you know VCS tool, do you know version control system, do you know all are same, okay, just like an synonyms, that's it. Don't be confused between different words. Version controlling system or source code management system or configuration management system, all are same, VCS, okay. They are just calling with the different names, that's it. Okay, now come back to the concept of your SVN client side. So client side, let's see what all the commands we have seen. I'm just going to, like, show you the individual commands. Now we have learned the important commands called SVN checkout, add, status, okay, uh, delete, update, log. What else? Okay, there are a few more out there, guys. Move, mkdir, and revert, diff. What else? Okay, guys, if you wanted to know all the list of commands, I'll give you one more important one, SVN help. This will give you all the list of commands. Can you see this? We already worked on log, okay. We already worked on commit. We already worked on checkout, okay. So commit is another important one. And every command is having a shortcut. If you clearly look at this, can you see commit is a shortcut in CI, checkout is CO, status, can you see status anywhere? Yeah, status is ST. If you wanted to check whether your ST is working or not, can you run the SVN ST command? It's working absolutely fine. I want to run the SVN update. UP is a shortcut. SVN update, working fine. Okay. So we have shortcuts as well. If you want to play around with the shortcuts, you can do that. Now I want to show you a couple of more commands. SVN mkdir. Okay. SVN mkdir is a command which will create a directory. That's it. Okay. SVN status, it's been created and you just commit it. That's it. SVN commit, add a new directory. Okay. So similarly, there is one more command called SVN info. that will give you information about your workspace, which is nothing but from which URL you checked out this one, okay, and what is the revision number you have it, when did you do it, author details, everything it will be there. Simple, some simple command. And there's one more command is there, which is really useful in the day-to-day job. I made some changes, blah 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 blah, okay, and I wanted to revert these changes, right? So to revert those changes, what you can do it, SVN revert hello.txt. That's it. It's been reverted now. If you want, you can cross check. Open this. Can you see? There are no changes. Okay, whatever I made, you don't find them. So that's what the revert command. What else? Revert, mkdir is move. Move is simple thing. In Linux, what exactly the move does? Same thing it will do it. Okay. SVN move or MV. Okay, DevOps is there. This I'm making as a DevOps. Can you see this? This has been renamed. Moving nothing but renamed. Okay. Now you can come at this. Right. So that's what the reward. And diff is nothing but which will show you the difference between two revisions or two latest revision or the changed file. Okay, now I made some changes, right? I wanted to know the diff. Okay, svn diff hello.txt. Can you see the changes? Revision number 6 and a working copy. Working copy is nothing but the modified one, and revision number 6 is the original file. And what is the changes is something you added here. Okay, so you can find the diff over here. But the thing is, this is called a console diff, and this is really difficult for or unified diff. This is really difficult for the developers to understand what changes has been done from the console. So typically we see the diff from the tortoise or UI client, okay, not from the command line client, because it's tough to understand from the command line client what's been different, because right now it's only one line, but tomorrow you have a 1,000-line Java file. Okay, comparing two revisions is really tough. Okay, so this is default compares your workspace and revision number 6, right? If you want to compare a particular revision, okay, like R2 with 5, it can compare. Can you see this? R2 and 5 are almost same. No new line at the end of the file. So can you see this? So if you can provide the two revisions as well to compare it. So that's about this set of commands, and there's a couple of more commands are there, which are export and import. Okay, what are export and import are? Without the client, you cannot push, without this workspace, not the client, without this workspace, you cannot push your files to your server, okay? And you cannot pull your files from the server. So you must and should have a workspace to perform any kind of a SVN client operations, right? So assume I'm a project manager, okay? I don't want to check out this entire source code, but I have a file lying over there in this, okay, example in DevOps directory. I have a file called SVN notes. Okay, now I want to send this file to my repository. How do you send it? Without creating a workspace. Okay, so that we can do it with the help of a command called SVN import SVN notes. Okay, and directly provide the URL of your repository. Okay, and SVN notes dot, you need to provide the file name at the end. Okay, then provide the message, because SVN import works like a commit command, guys. Direct commit on the repository without having any kind of a workspace. Okay, so importing this special file. Look at this, it's pushed now, and it is incremented the revision number 9, and you can check it out over here. Can you see this SVN notes here? The notes, whatever you're trying to prepare over here, right? So you might be thinking that why people check out the workspace and do all this stuff. We can do it directly with the help of import. Yes, you can do it, but think about you made some changes now in SVN notes. Okay, now SVN notes I saved it. Okay, so now you try to import it again, you can't import. So with the help of the import, you can send the file only once. Okay, not more than once. But think about the developer. Developer will keep add the same file n number of times, right? But so when he keep adding the changes, right, he cannot, if you cannot push it in second time, there is no use of it. So this import is only for the guys who rarely use SVN for one time task. Okay, like one time pushing, that's it, right? So that's about the import one. And similarly, there is one more command is called export. This is the reverse of import, which is nothing but import is pushing to the repository, export is pulling from the repository. Like somebody wants I want this hello.java.txt file. Okay, copy this, paste it. That's it. The file has been downloaded. If you want, you can cross check it. Can you see this? This file is not there earlier here. If you want, I can delete once and I can run the same command one more time. Can you see this? The file has been downloaded. So you might be thinking, what is the difference between checkout and this? See, this is just downloading it, but in after downloading it, you cannot work on this file because this is exported one. Okay, which doesn't mean to work and push it back. Okay, so if you make use of the proper workspace, right, you can push it back. Otherwise, you cannot push it. So the difference between the export and checkout is using checkout. Okay, we can pull the code and you can work on the code. But using export, you can pull the code, but you cannot work on the code. And one more difference is in workspace, you can find .svn hidden folder. Okay, now look at this. If I try to check out this Subversion folder, okay, in something like SVN EX, okay, look at this, come back here, can you see SVN EX? This is checked out entire code, okay, but the difference between this and your Subversion folder is, okay, your Subversion folder, all SVN commands will work, but not on your here in exported one. Can you see SVN status will not work because this just downloads the code. It won't allow you to work with your SVN client commands. It says clearly it's not a working copy. Okay, but if you go to the now run the SVN status. It clearly says the command is working and it will show you the results as well. Okay, so that's the difference between export and the checkout command. This is important. People may ask you some questions, the difference between a check-in and import and export and checkout. Okay, so these are the set of commands which we'll be using in a day-to-day life to communicate with our SVN server. Okay, and this is all about the SVN command and client phase. Okay, and similarly we have one more client called tortoise client that we'll see it later. It's not so important. Okay, let's move on to the server side. The other topic is administration topic. Okay, now we need to get into the administration topic and perform some administration tasks. Okay, so before performing the administration task, there is one more topic left over here, branching strategy. This is a really important topic, especially when you're dealing with version controlling systems or source code management systems, whatever you call it as. So what exactly a branching strategy means is, okay, so now you're storing the source code and you're maintaining them properly, everything is good. But yesterday, if you remember, I told you one more reason for having the source code management system. What is it? Parallel releases. Did you see this? Parallel releases. Okay, now I'll explain you what do you mean by parallel releases. See, in an organization, everybody works for the software development. Everybody works for the source code development part. Okay, like if a project is there, okay, and they'll not work on this project never ending. Okay, they will be having some milestones. A milestone nothing but they're gonna complete some features and give it to the customer. Okay, release to customer, that is called milestone 1, and after that they'll start again some features and release to the customer. They call this as a milestone 2. Okay, milestone 2 release. And similarly so this is how typically anyone do the code development, okay, or application development or product development, whatever you call it, and they release to the customer. They don't do all together and release at the end of the 2 years or 3 years. They finish something and they give it to the customer. So whatever they do in this span of time, right, okay, and that we call as a release, okay, and this can be 6 months or 1 year or 2 months or 2 weeks, doesn't matter. It depends upon your life cycle process, okay, based on your what kind of a process model you're following, what kind of a SDLC process you're using. Okay, it depends on all those stuff. Now the thing is, think about when you release the M1, okay, and and after that your customer is looking for some features and you're starting with M2. Okay, assume when you release M1, right, and your customer asks M2, okay, now in between, while M2 is in development, okay, if your customer come and ask you to develop M3, another set of changes, okay, and you have to start immediately, and again, and one more time, one more thing, before you complete M3, your customer may come and ask you like, M4, M4 nothing but another set of changes. So at once you might be thinking like, you will be doing 3 releases at a time. Can you see 1, 2, 3? So parallelly, so you have to work parallelly on 3 releases. Okay, how do you manage this parallelly working on 3 releases in your version controlling system or source code management system? Because in source code management, in your source code, right, you will be having only one location to store your code. Okay, so you will push all your code over here. So how do you push your M2 code here, or M3 code, or M4 code? Okay, there will be definitely conflicts. Okay, and because while M2 is going on now development, if somebody from the M3, they push a code which is breaking the code of M2, right? So that is not going to work out for like your process. So you may need like a an easy process to manage different releases in a single source code management system. Okay, so that's where branching strategy comes into the picture. Okay, now that's where you need to like uh, what do you call, follow some standards, especially when you're storing source code on your version controlling system like SVN repositories and all. Now you're directly blindly pushing the code into your repository by pushing it to the root location, which is a slash. Okay, instead of that, what we will do is we'll try to arrange them in a proper way. A simple example, guys, when you purchase a laptop with 1 TB size, will you create only one drive and install the OS there and work on the same drive? Only see, no, right? You partition to the different drives and you work on it. So that's called better management of your space. Okay, similarly, when you are dealing with source code, you should deal your source code in such a way that you should be able to manage it properly. Okay, and provide a solution for different problems which occurs in your software development process. Okay, so now if this is what the scenario, how are you going to manage? So that's what the solution I'm going to give you now. So come back, SVN update. Now what I will do, I'll first try to create a standard directory structure, like a folder called trunk, branches, and tags. This is a standard directory structure followed by the industry. Okay, I'll explain you what do you mean by trunk, what do you mean by branches, what do you mean by tags. Okay, for right now, try to create 3 empty directories on your root location: mkdir, trunk, branches, tags. Okay, now try to commit all of them. Added structure. Right, now all are committed. 3 empty directories. Now the thing is, I don't want this source code stuff in outside of this root directory. I want that to be part of my trunk. What do you mean by trunk? Is here exactly the source code contained. The source code should be the source code should be there in the trunk, not on any other locations parallel to the trunk and all. You shouldn't keep any kind of a code over there. So let's try to move our entire source code into the trunk, guys. Okay, I'm just moving one by one, all of them. SVN move. Trunk is something like what do you call, a directory name. You can give any name. It need not be trunk. You can call like main okay, main location, or like you can call it as like a parent. Okay, so that is the location where we will be moving our code. Okay, and we will maintain in a particular location. Simple thing, guys. If I'll tell you one thing. Treat it like this is your C drive, okay, or master drive. Okay, I'm trying to create a multiple sub drive so that I can manage the code very well. Okay, and I'm giving some names to it, and this can be any name. It need not be trunk, guys. Trunk is given by industry people, like most of the people follow trunk. You can call this as a master, or you can call this as a parent. You can give any name, some name I'm giving. Okay, and I'm creating a directory and I'm pushing all my code into that folder. That's it. Don't treat it like trunk is some different feature or something else. It's a plain directory for SVN. That's it. That's it. Are we done? Yeah, we are done. Now try to commit your changes. Mode source code to trunk. Now come back here and check it out. Guys, can you see now? It's well formed now. I have 3 folders, branches, stacks and trunk, and my trunk contains entire source code. Okay, and my source code is not there anywhere else. Right. Now, if you have this kind of a directory structure on your repository, okay, now I'll give a solution to, like, how to manage for this kind of a situation, how to manage this kind of a scenario. Okay, now once you have the source code in trunk, right, so what will happen? Okay, when you have a, assume, like, trunk contains now, okay, src is now m1 code, guys. Okay, m1 nothing but the first release is already done. Okay, now you are scheduling m2 release. Now when you are running on m2 release, you may expect m3 m4 come in between before you complete m2, right? What you will do it, instead of working on trunk, okay, please try to create a branch from the trunk, okay, and do the m2 development over here. You're getting my point. Okay, m2 development over here. So sorry, so src m1 plus m2. Okay, now you might be thinking, what is src m1? So guys, this src m1 is, we will be creating a branch out of trunk inside the branches. What do you mean by that? Is I will copy this code into the branches, okay, and I will ask the m2 developers to, guys, please don't work on trunk, please work on the branches location. This is called branching. Branching nothing but copying the code from one location to other location in your SVN repository. Okay, and tomorrow if it is m3, then I will try to create one more branch, okay, src m1 plus m3, okay, and again src tomorrow something else, okay, another release, okay, m1 plus m4. So I will be giving a dedicated location to each and every team, so that there won't be any conflicts between their commits. Okay, people can work independently and they won't be having any kind of issues. Okay, this is what I'm trying to achieve actually. So a proper management of my source code in a source code management tool, and giving a feasibility to the developers where they can work without having any issues on with respect to their code base. Okay, and they won't be getting any kind of a conflicts and all. So let's try to perform this activity. Okay, now I need to create a branch for m2 release. Okay, so let's try to create a branch for m2 release. So that can be done with a command called svn copy. Okay, and branching can be done directly with the URLs. Okay, so trunk is my source code, right? So take this copy URL. Okay, and where do you want to create the branch? I want to create the branch inside the branches. Copy this branches folder, and once you provide the URL, right, you have to provide the branch name m2. I'm providing my branch name m2, and try to provide a message as well, saying, like, creating m2 from trunk. That's it. Anything wrong, guys? Something went wrong. Okay, so yeah, creating m2 from trunk. This looks good. So the branch has been created now. If you want, you can cross check it. Can you see branches is empty? Try to refresh. Did you see m2 here now? Okay, and you can see m2 entire code. So now in m2, what do you have now at the moment? You have the src m1. Okay, now what I will do, I'll give this branch to my developers. Okay, who's are there? So assume, like, these people are working on m2. Okay, svn checkout m2, they can work on m2, directly get it to the m2, and they can start working on it, and that's how these people will be given a dedicated location and they can work on it. So similarly, you can create m3, m4 and all. Okay, so let's try to create m3 and m4 from the same thing. Okay, same trunk m3, and you just give a different name m3. Okay, and similarly m4. Okay, that's it. So you have n number of branches now, and people have a different locations. Can you see this? M3, M4. Okay, you might be thinking, if you keep creating like these branches, right, I mean, do you think, like, the space is sufficient enough on your repository? Guys, this is nothing to do with the space. In backend, the Subversion will maintain some symbolic links between this location, but actually it maintains only one copy of it. Okay, it's a kind of a mirror for us. Okay, it's just a view, but in backend, the common things to maintain a single disk. Okay, so only the changes will be stored over here, not the actual physical copy of it. Okay, so that's the reason you can create n number of branches, and the branch creation is very quick. Even if your trunk contains 10 GB code, copying to a new branch will take half a second. Okay, but typically 10 GB copy from one location to other location, do you think it will finish in 1 second? No, right? It takes so much of time because it is creating another copy. But in SVN, it is not creating another copy. It is giving a symbolic link or a kind of a view to you, okay, so that you can feel separate section and you're working on a separate thing, okay, and what are the commits you made, it will store them as a separate one, okay. So it stores only the delta part, which is the diff part. It will not store the actual physical copy of your branch. Okay, so any questions still here? Were you able to follow the branching stuff? It is a little tricky. Please try to understand. Any queries still here? Guys, were you able to follow?
Yes.
Okay, yeah, thanks so much. So now I created 3 branches, right? So creating the branches is done. Okay, now people are started working on it. But how do you think the release process will work? Now it's a time for M2 to release to the customer. Okay, now when this guy is releasing to the customer, he is happy. Okay, because the customer is already having M1. Okay, now you are releasing M2. Okay, so we'll answer your question. Okay, just wait for some time. So the customer is already having M1, and after this release he is having M2 as well, okay, and he is happy. Now look at this scenario, M3. When it comes to M3, the customer is having what already? M1 plus M2. Am I right? The customer is already having M1 plus M2. With this release, okay, you are supposed to add the M3. But you know what is happening? You are trying to give him M1 plus M3, which is nothing but you are not giving the M2. You are trying to override the M2 here. I'll explain you your questions. Okay, just give me some time. Let me complete this. Okay. Now, when it comes to the M4, same issue. When you try to deploy this to the customer, right, you will be deploying M1 plus M4. Okay. When you do this, right, you are overriding. Okay, you are overriding M1 and M2. M1 and M2. Okay, here you are overriding M1. Okay, so this is not an ideal process to implement it in a project, because if you are trying to override some code in the production, nothing but that is not going to be a small issue. It's a big issue, like you are overriding the earlier features. Let me give you a good example to explain the scenario. Okay, so you can map it to the real world. Now you are working for a banking client, guys. Assume you are working for a banking client. Okay, so there is something like core banking solutions. Okay, this is what one release. Okay, M1, and another release, like you are doing it as a credit cards, treat it like a M2. Okay, and another release mortgages, treat it like M3. Okay, another release like uh, financial planning or insurance. Okay, insurance, treat it like a M4. Okay, now what I'm trying to say is, initially, okay, before M2 go to the production, right, in production nothing but in the servers, which is accessed by your customers, okay, is already their core banking solutions. Okay, now when you are trying to release M2, okay, so when you're trying to release M2, right, you are trying to release M2. M2 is having core banking as well as your credit cards. That's pretty good. Core banking plus credit cards. Okay, so he is happy over here as well. Okay, and here is anyway happy. Now when it comes to the M3 release, okay, what you're trying to release? Core banking, okay, plus mortgages. Did you see now what is happening? Credit cards you're trying to override actually. Okay, that is not an ideal solution. So you shouldn't override existing features. Now he is worried now actually. Okay, he is worried. He is saying like what happened to my credit card feature. Okay, and same thing with M4 as well. When you're trying to release M4, right, you're releasing core banking plus insurance. Okay, right, rest all are gone. Okay, you don't have a credit card, you don't have mortgage, anything. So this is how it works. So this is what the problem of our current branching strategy. Now what is the solution to avoid this problem? Okay, the solution is going to be merging. Okay, so with the help of the merging concept, we can sort out, okay, this problem, and we can give a proper running branching strategy to our our release process. Okay, so that uh, the customers will be having the full-fledged code base in the production, and they won't be having any issues. Okay, and this we need to implement it. Now how do we do this merge? Okay, so merging is typically nothing but merging two set of codes, okay, together and releasing it. Okay, that's called the merging. It's a typical English meaning, right? Now that we are going to do it with our SVN branching strategy. Okay, now let me show you here how to do the merge. Now when you're trying to release, see, uh, these two releases are happy. I mean, there is no problem at all. Okay, I don't think any merging is required. But when you look at the third release, okay, here something is missing. Okay, what is missing, guys? M1 is missing here. Okay, so you may need M1 over here in your branch. So where is M1 available? Okay, in trunk it is, sorry, not M1, guys, M2. M2 is required. Okay, so where is M2 is available? In M2 branch. So what we need to do it, we need to merge, okay, M2 with M3, then you can get the M2 one. So you might be thinking, when you do the merge from M2 to M3, will it not merge as M1 again? If you have M1, if your source is having M1, if your destination is having M1, it will not merge. Only the delta part, the diff part, it will merge it actually. Okay, so M2 to M2 will merge it over here. Then you have full-fledged like your entire code base. Then you can do the deployment into the production. Same thing here. Here what is missing? M2 is missing, M3 is missing. So where are M2 and M3 is available? They are available in your branch 3. Okay, if you merge branch 3 with branch 4, M3 with M4, you'll get all those things. Okay, so this is how we do the merging, right? Now that merging I'll try to show you practically. Okay, first merge. Okay, before doing the merging, let's make some changes. See, to reflect the merge, right, there should be some changes. Okay, so let me make some changes into each and every branch. SVN checkout. Let's make some changes to M2. M2. Okay, so echo hello a.txt. I'm just creating a new file. SVN add a.txt, SVN commit -n, added a.txt in M2, some comment. Okay, so this is done. Now come back. Now SVN checkout, I can use shortcode checkout. M3 now. Now get into the M3. Okay, now M3 is doing somewhat like he's doing some changes now. Assume like hello SVN add M3.txt, SVN commit -n, added M3.txt in M3 branch. Okay, now I have some changes over here, right? Assume like the M2 has been already released to the production. Okay, now M3 is ready for the production. So when M3 is ready for the production, what you can do it, SVN, try to update yourself. Okay, SVN merge M2. When you do this, right, M2 changes will drop it into your branch. Look at this. Sorry, you should do the, I mean, you should provide the entire URL, guys. Okay, not the just branch name. I was just following the Git, but in Git is not required. In SVN you have to provide the entire branch URL. Can you see this now? You have a.txt dropped into your M3 branch. Okay, and you can check it out that a.txt is there. Okay, so now you can commit this branch by saying like M2 merged with M3. That's it. So this is how you do the merge now. Now in your look at this. You have a M3 file and you have a.txt. M3 is your changes and a.txt is the M2 changes. Okay. So this is how you can get the other branch data. Now similarly, if you go to the M4 as well. Okay. Now SVN checkout M4. Okay. Get to the M4. Now SVN merge. Okay. And say M3. Now you will get M2, M3 both the changes, which is a.txt and M3.txt. Can you see this? A.txt and M3.txt. Okay, and you look at the status, you have both the files. Now you can commit these files in your M4 branch. Okay, merged M3 with M4 to get M2 and M3. That's it. Okay, so this is how we do the merge, so that we will have all the changes, okay, and we won't be missing any of the previous release changes, and we should be able to push it to the production without any issues. Okay, so this is called merging stuff, guys. Okay, typically merging will happen like this. Okay, you will be checking out the destination branch. Okay, where do you want to merge? Suppose like my merge is like this. I want to merge from M2 to M3. If this is what your merge plan, okay, then you have to check out the destination. So M2 is your source. This is what your source, okay, and M3 is your destination, right? So typically we need to, always we need to check out the destination. So we should do the merge on your destination. So what will happen when you do the checkout, SVN checkout, destination is M3. So now get into the M3 workspace, run SVN merge command, and you need to provide source. Source is what here? M2. Okay, so if when you do this, you will get the M2 changes into your local workspace, which is M3 workspace. Then you can commit them into your branch, so that your changes are there in your M3 branch. Okay, so the same concept for the M3 to M4 as well. Okay, so this is how we do the merging, guys. I know it is little difficult to understand in the first attempt. Okay, please go through the video again, okay, and try to perform the SVN client commands first, then come to the merging strategy. Okay, so don't start the merging in the branching and merging in the starting itself. Try to practice the SVN commands first, then come out of here. Okay, and I can send you a couple of links as well where we have a good branching strategy, and just play around it. And there are some articles in the few blogs are there. I'll send you those articles as well. Okay, there is one SVN branching strategies. The many are there. Future branches is not required. Okay, I'm looking for Atlassian one. Okay, this is. So it would be better if some graphical representation is there. I don't see any graphical representation of here. All are explanations, guys. Okay, you need to go through the explanations. Okay, I don't see any kind of a graphical images where I can show you how the branding has been made. Okay, but for Git I have many references. I can show it in the Git very well. Okay, for SVN, guys, this is how it works. Okay, so you have to create the branches and do the merge manually. Okay, and push it to your SVN server. This type of branching we call it as a parallel branch. Parallel branching strategy, and this is widely used in most of the organizations who are using the SVN as their version controlling system. Okay, so this is all about the branching stuff. So it's time now. Okay, guys, we are running out of the time now. So what I will do, I'll stop it for here. The administration stuff tomorrow I'll start, and we'll try to finish off the administration stuff. and I'll show you how to create the users and passwords and provide the access, okay, and write some small hooks, okay, SVN hooks, which are typically handled on the server side, okay. So all the stuff we'll see, okay. That's important session because the actual work which you do is administration, okay. The client side part we don't do much because that is taken care of by the developers, okay. Our job is to, like, mainly take care of our SVN server by doing the administration. So we'll see that administration section tomorrow, okay. So if you have any question, post in the email group or you can post it in the WhatsApp group and you ask me, I can answer you. And somebody is pinging over here, what is it? Install the Visual SVN server. Please don't install any other flavors of SVN. There are many SVN servers are there. Visual SVN, Collaborate SVN, Silk SVN. Okay. If you go to the page over here, where is it? Okay, here. Uh, can you see this? Collaborate, Silk, Tortoise, Visual SVN. See, the many are available, but the thing is, if you go for the core one, the Win32 SVN is the core one, okay, which is actually developed by the Apache people, okay. That will be easy and we will get the base SVN. These are all the kind of, like, flavors on top of your core SVN. They provide some UI features to you, okay, so that you can easily manage it. But don't go for that because if you stuck anywhere and if you need some help and all, they'll charge for the support and all, okay. So go for the plain SVN stuff. Yeah, that's what, but it's showing default as trunk nothing but. See, before you create the trunk branches and all, the Visual SVN server guys, they already created the branches for you. Something ready-madely they are giving. See, in my session I'm trying to explain you why we need to create the trunk and all, okay. But in Visual SVN server, which you already installed and working, right, they already created trunk nothing but they're expecting you to follow the standards, okay. So that's the only difference. Now in our core SVN, we set up everything, okay. Did I answer your question? Who's over pinging this? Yeah. Okay, guys. Thanks so much. That's it for today. We'll catch up tomorrow with the administration session. Okay. See you all.